All right, welcome class. This is video for the handout 8.2, Circles in Pi. Okay, so we're going to go through the handout and I'll just comment and kind of work out some of these examples. First, number one is we need to draw 3 circles. Okay, 8.2 circles and pi. And draw 3 circles and with equal radii. Well, it doesn't matter really because these circles are just for labeling. On your handout, you can draw 3 circles that with the same radii with your compass and just practice doing that. And it's just easier just to keep drawing one circle and the next and the next. So 3 radii, that's why they say that they could be the same. But really, we're just kind of going over some definitions. So I'm going to draw 3 circles here. Okay, we'll pretend those are circles. It says mark each circle with center P. Okay, after you've done drawing your circle with your compass, mark it with P as your center. You can look at where the compass needle had poked the hole into the paper probably a little bit. Mark them with P. What is this? On the first circle, draw a line segment from the center to any point on the circle. So there's one right there. What is this segment called? Well, as you probably can guess already, that's called the radius. Okay, and if you want that singular, but if you want plural, we call it radii. Okay. On the second circle, draw a line segment not through the middle, with both endpoints on the circle. And so they're referring to this right here. We draw one endpoint here, draw one endpoint here. Okay. This segment is called a chord, C-H-O-R-D. Okay. It's just a line segment from one point of one end of the circle to the other. And then on the third circle, draw a chord that goes through the center. Okay. What is this segment called? So we have this segment here, right through the center. And as you remember, this is called the diameter. Okay. So that's number 1. Let's go on to number 2. The definition of a circle, we haven't stressed this too much in this class as much as I like. The definition of a circle. A circle is the set of all points the same distance from the center. That's the most basic definition that we discussed in this class. So all of these points on these circles, so I drew a curve, but the curve actually consists of infinitely many points, the set of all points. Okay, so I drew out a few of them on the circle above. First circle in number 1. Okay. Now the book, or the handout here, kind of models the book definition, so here's a more technical definition, but you need to know more intuitive definitions for your students. Okay, a circle with center P and radius R is the set of all points in a plane that are the same distance, or you can say equidistant, from the center P. Okay, equidistant or R, that are R distance, that are the distance R. Let's go back that way. You can even use that word instead of equidistant. Those are more technical definitions, but I like this one the best, just to keep it simple. Okay, the circumference of a circle. So that's number 3. Some more definitions here. The circumference of a circle. Circumference of a circle is the distance around the outside of the circle. Okay, and you can also think of it as kind of like the perimeter of the circle. Okay, so remember the circumference is a distance, so it'll be one-dimensional. Okay, next video. Alright class, welcome to the next video. This is number 4, activity number 4 of our handout for 8.2, circles and pi. And we studied a little bit about circles, but let's see what happens in this next discovery. In this activity, you need to draw 3 circles of different sizes. We need to find the circumference and diameter of each. Okay, so I have drawn 3 circles here, and I'm going to, this is circle number 1, this is circle number 2, and this is circle number 3. Now what you're going to do in your handout is use your compass to draw these circles, and that way you'll have more perfect circles than I do, and you can make better measurements. For the first circle, I'm going to need to measure the circumference. Okay. And if you recall, the circumference is the distance all the way around the outside of the circle. Okay. And to do this, I need some sort of curving measuring device that can curve. And so what I've done is I've went to my mom's sewing cabinet, and pulled out her measuring tape that is for sewing. And so those are curved measuring devices. Okay. And so what I did with circle number 1, circle number 1 is wrap the circle measuring tape for sewing in around the circle, and I can measure that. And when I did that, I got 14.5 centimeters. Okay, and so I'm using centimeters to the nearest tenth of a centimeter to help with the calculations here to be more precise. Now the next step is that to find the circumference, it says for find the circumference and diameter of each circle. Okay, so now we're going to look at the diameter. Okay, you can use a ruler or the tape measure again to measure the diameter, the distance from one end of the circle to the other through the center. And the diameter of this circle number 1 is 4.7 centimeters. Okay, so circle number 2, let's go ahead and measure the circumference and diameter of that. Now notice that circle number 2 is a smaller circle. It's the smallest one of the 3 I've drawn. And we're going to discover a property that happens with circles, circumferences, and their diameters. Okay, so the circumference of this circle is equal to 8.5 centimeters. And the diameter is equal to 2.7 centimeters. Okay, again, I'm using the measuring tape to measure around the circle. Okay. So here I'm going to do it in blue. I'm going to measure, kind of show you where I'm measuring around the circle this way. And then green is the diameter. So the blue is the circumference, the green is the diameter this way. Okay. And so we have the circumference is the blue, and the green is the diameter here. So we measure those together. I'm just kind of gathering measurements now. Circle number 3, we have a circumference of 13 centimeters. The diameter is going to be 4.2 centimeters. Okay. After in activity number 4, this discovery, we have finding the ratio circumference to diameter of each, okay, to 2 decimal places. And so we're going to do circumference divided by diameter. And this ratio for circle number 1 is 14.5 centimeters divided by 4.7 centimeters. And when we're dividing these, the centimeters will cancel and I'll get a number. And this number is going to be 3.09. So I do the decimal form to 2 rounded to the hundredths place, 3.09. Okay, so let's go ahead and calculate that for circle number 2. Circumference divided by diameter is 8.5 centimeters divided by 2.7 centimeters. And the centimeters will cancel, and we have a number that is 3.15. Okay, 3.15. The circumference over the diameter divided by the diameter for circle number 3 is 13 centimeters divided by 4.2 centimeters. The centimeters will cancel, and we have a number of 3.10. Okay. What do you notice about the ratio for each? Okay. Isn't it interesting that the ratio, you notice, circle number 1 is 3 and a little bit, circle number 2 is 3 and a little bit, and circle number 3 is 3 and a little bit. Okay, so we notice that the ratios are just over 3. Okay. And so that's what's the property for these circles that's in common with every circle. Okay, so if you take the circumference of every circle divided by the diameter of every circle, then we get the same number. Okay, and the Greeks were the ones who kind of popularized this idea enough that we took their approach on for naming this number. Okay, and the name is pi. In the Greek letter pi, it looks like that. We spell it pi in our language, and it's just the ratio of the circumference of a circle divided by the diameter Okay, so let's just say that again in your mind. Pi is the ratio of the circumference divided by the diameter. Okay. So we have the circumference divided by the diameter. Okay, so that's what pi is. And pi will help us with calculations. Now, remember how hard it was to measure the curve of the circumference with the measuring device. Okay, so we're going to look at this ratio, that pi. We're going to set that equal to pi. So pi is going to be equal to the circumference divided by the diameter. Okay, and we want to be able to find circumference in an easier way. Okay, now it's easy to measure the diameter. We put our measuring tool straight across the circle. Okay, and it's easy to know pi. Okay, because pi is the approximation to pi is a couple of things. So let's go and say, okay, so pi is approximately equal to, we all know the 3.14 version, that's the decimal version, but pi is also really close to 22/7, okay, as a fraction form. And so we'll use 22/7 a little bit in our homework so that you can get used to what that's like. So pi is approximately equal to 3.14, and pi is approximately equal to 22/7. Okay, so we're saying back to here that pi is the same as the circumference divided by the diameter, and we did not want to measure the circumference or find it using our tape anymore because it was tricky. Okay, so let's go ahead and isolate our circumference so that we can just know how it relates to pi and the diameter. Okay. So we're going to multiply both sides by c. Let me go ahead and do that first, and then we'll do that arrow. Okay, so multiply by c, multiply by c. Okay. And then when we do that, we get that this sorry, not multiply by c. Let me back up. That won't help us any. We multiply by d. Okay, can we get c by itself? Apologize for that. Multiply by d. Okay, the d's will simplify there. And we have the circumference is equal to pi times the diameter. Okay, so I'm taking this part here. And we know that pi is 3.14 or 22/7. The diameter is easy to measure. Okay, so all right, one more thing that I didn't mention before about this equation here, this one right here, c equals pi times diameter. Also in the book, and as you might have known, is that we can substitute in the diameter is equal to twice the radius. Okay, so all diameters are twice the radius. And when I do that, I can also have the circumference equal to 2, back that up a bit, pi times 2r, which is also equal to, circumference could be equal to 2 pi r. Okay, so there's another one that's a circumference equation with pi times diameter and 2 pi r. Okay, so clearing that, we're going to move on to number 5, more terms. Okay, so in a circle, number 5. In a circle, the central angle. Okay, so we have a central angle, and I'm just going to do the vocab like this, central angle. So you have your circle, you have your center, and the central angle of a circle is just any angle whose vertex is at the center of the circle. Okay, so that's a central angle. Next one is an arc. ARC is an arc. Okay, so an arc is a circle where the central angle is drawn out, and it's the part of the circle that spans some of the circumference. Okay, and so we're going to do like this part right here. It's kind of like a little curve here. Okay, it spans some of the circumference, so that it's not all the way around the circle. Okay, and then the central angle is this part right here. This angle. Vertex is at the center. That's your central angle, and then that's the arc. The sector the sector of a circle is the portion of the disk that lies within the central angle. Okay? So a portion of the disk that lies within the central angle. So we have our circle, and we have a portion of this that lies in the central angle. So I'm going to draw my central angle this way, because my screen's being funny. Okay, there's a central angle, center at the vertex, vertex at the center, and this is going to be this part. This is a sector. So you shade in this part of the circle. So an arc is part of the circumference. The sector is part of the area of the circle, and we're going to study more about area in the next section, 8.3. And we can measure all of these. Okay. So we can measure, so this is number 6 in our handout. We can measure the central angle. This was number 6. Measure with degrees. Okay. We can measure the radius. Okay. Here's a radius, which is one part of the measure with length units. Okay, measure the radius. You can measure the length of the arc. Okay, so usually we take to measure the arc, we'll take the whole circumference and then find the length of the circumference. Then we also find how many degrees this is, which is just a part of the whole 360. Okay, we use that to help us, and we'll show you how to do that in the next example. Alright class, welcome to our final video. This is an example of where we can use some of the information that we've learned in solving a problem or a problem situation. Now, we need to find, in number 7, it says find the perimeter of sector OPQ. So I'm going to highlight sector OPQ in blue here. So OPQ, now Q is all the way over here. We're looking for a sector. Okay. So we're going to find this area here. No, not this area. I'm going to find this perimeter here of OPQ. Now, O and P is given as a radius with 14 meters long, and so we can deduce that the other radii are also 14 meters. So OQ is going to be 14 meters. All right, but what the one that will take the longest to calculate is my arc right here, the arc PQ. Okay. So the sector consists of length radius OP plus radius OQ and plus PQ arc. Now you show that by this little symbol. We won't use this much in class, but we could possibly use it, and you could possibly see it in the future. Now OP and OQ are 14 meters each, so we can substitute that in. But PQ is a little bit different to calculate. It's a little bit, so it's an arc. Okay, and as I said before, we're going to take a look at the arc as a portion of the entire circumference. Okay. Arc is part of circumference. And our clue is going to be the central angle. Okay. Notice that the central angle is 150 degrees. Okay, so we're going to set up a proportion, okay, because we know that 150 degrees related to 360 degrees is the same relationship as arc length is to circumference. Okay. And so what we need to do is we need to calculate the circumference. Now the circumference, arc length, we don't know what it is, that's what we're looking for, but we do need to know what the circumference is so that we can solve for the arc length variable. Now circumference is equal to pi times diameter, or 2 pi r. In this case, we have the radius is 14 meters, so we'll just go with, it doesn't really matter which one, so we're going to go with 2 pi r. And we use 3.14 as pi, because that's what it says in the directions. The radius is 14 meters. Okay, so when I use that, I calculate this in my calculator. I do 2 times 3.14 times 14, and I get 87.92 meters. Okay, so I'm using 2 decimal places because pi is written in 2 decimal places. And so we can substitute that into our equation, our proportion here. 150 degrees divided by 360 degrees is equal to arc length divided by 87.92 meters. Okay, when we cross multiply, we have 150 degrees multiplied by 87.92 meters. Oops, let's try that right here. Which is equal to arc length times 360 degrees. Okay, so we need to solve it for arc length, and when we do that, we get the arc length to be 36.63 meters. Okay. And so I'm going to substitute that back in. To this equation. When I add these up, I get 14 plus 36.63. And we get 64.63 meters. Oops. Okay, so this right here is my answer for the area, for the length of that perimeter, that sector. Okay, so that's the video, and hope you guys enjoyed the lesson. I like the lesson on discovering pi. Remember, pi is the ratio of the circumference to the diameter. All right, class, there's actually one practice homework problem that I'd like to do with you guys, and I'll go ahead and give you the setup. The homework for this section won't be was combined with the next section, 8.3, so we won't assign the homework until we get through Wednesday's class on section 8.3, which is area of circles. So we have perimeter and area of circles together. Now here's a perimeter problem, circumference problem, circumference and area of circles. And so we have a running track. Okay, so this is actually problem number 1 from the homework. We have a running track situation where we have a circle, sorry about that, okay. We have a circle here, okay, there's half a circle here, and then we have this distance here for one of the part of the tracks, and this is for the other part of the track, and we cap it off with another half circle. Okay, so these ones right here are half circles or semicircles. Okay, and we have a distance here. And this distance right here is 70 meters. And we have another distance here across the top. This one is 90 meters. Okay, and so it's all symmetrical, so that means this distance right here is 70 meters, and this distance right here is also 90 meters. Okay, so 70 meters is the diameter of the half circle. 90 meters is just the length of the rectangle that's inside these two half circles. Now what we need to do is we need to find the length of the track. Okay, and we're going to use pi equals 22/7. Okay. All right, so the length around the track. We have, essentially we have, so our plan, and this is what I want you guys to try and do throughout the next few homeworks, is to label each of the parts that you're finding the length or the area of. Okay, each of these parts. And so we have we need the circumference of one circle, because these are two halves right here. Okay, so we have this half, we have this half. So we find the circumference of one circle, and we'll take care of the lengths of both of those halves. Okay. Circumference of one circle. So the circumference is equal to pi times diameter, and I'm going to use diameter because it's given to me as 70 meters. Okay. Now pi is going to be 22/7 times the diameter of 70 meters. Okay, now it just so happens that these two can simplify before we multiply. So that's 7 and that's 70. I can divide both by 7. That becomes 1, becomes 10. And so we have the circumference as 220 meters. Okay. And so I'm going to add that on to the 90 and the 90. Okay, so rectangle, I'll call those the rectangle lengths. These are the rectangle lengths right here. So in green, I've highlighted this distance and this distance. Okay. Each one are 90 meters each. Which gives me a length of 180 meters. So I'm going to combine the circumference with the rectangle lengths to get the length of the whole track. Okay, so we're going to do 220 meters plus 180 meters. When we add those together, we get 400 meters, which makes sense because tracks are 400 meters long. Okay? So the calculation of the circumference is an important part in this section here. So there's that one.